You guys, it's all your fault that I didn't hit record. I told you all to remind me, and not a single one of you did.
Remember to press record.
So guys, likewise, what would it mean for a value to be a maximum?
F of c is greater than f of x for all x.
That at f of c, so c is there's a maximum at x equals c, whose value is f of c. If f of c is bigger than all of the other y values, or f of x, for all x. And there are three different ways we could see a maximum. Okay? We have global, sometimes we call them absolute maxes. Which one did Mrs. Turner use?
Absolute.
Okay, so I'll try to use absolute. Okay? And then absolute max happens when it is the maximumist. Is that a word?
The highest.
Of all maximums.
Maximum.
How is that? Is that a good definition? The maximamists? And likewise, the minimumist of all minimums? Okay, what about a local one? Did she use local or relative? Both? I like local. It feels a little bit more cozy to me. It's just if I say any high / low point, is that okay?
Yeah.
To the top of a hill. And then if we're talking about a max or a min on an interval, we could have a function that looks like this, where the minimum could just be, not because it could happen at the endpoints, basically. Is everybody good? Okay. So just because we have an interval doesn't mean we have all maxes and mins. So for example, if I look at this particular graph, this point right here is not a value of the function. It just keeps getting closer and closer and closer to that point without ever being a maximum. So even though it's an interval and it's stopped at that point, that doesn't mean there's a maximum. Does that kind of make sense? Okay. All right, so here we have three different graphs, and we can see the maximums, right? We got one here, here, a minimum here, a max and a min. Okay? So my question for you guys is not where is the maximum, but rather, what is the value for the derivative of that function at that max or min? 0. So like when we look at, say, the tangent line, pull it down so I can reach it. When we look at the tangent line here, we can see that the slope of that tangent line would be 0, yes? Okay, so we have 0. What about this one? This is a cusp, yes, or a point? So the value for the derivative at that minimum is undefined. What about here? Maxes and mins. If we think about that slope of that tangent line, where would it be? 0. Anything groundbreaking for you guys yet? Okay, cool. All right, now we can have a function. Critical numbers occur in two different places, either where the derivative equals 0, or the derivative is undefined. If you guys have done critical numbers before, right? And here's the deal. all relative extrema where things happen at critical numbers. So,
Is that because, like, maximum extrema can be at endpoints?
or endpoints. Cool? So, thinking about the value of the derivative, okay? When we think about that mean value theorem, right? Remember how we kind of talked about if you had a f, if the value of f is positive at one point and negative at the other point, we'd have to go through 0 if it was continuous, right? So that's how we have a positive slope and a negative slope. We kind of talked about those ideas, okay? So it's either got to go through 0 or it was undefined somewhere, and that's what caused that tangent line to change sign. That's why it occurs at critical numbers. Does that answer your question? Okay. So, if I ask you to find the extrema on a certain interval, what I would expect you to do first is say, well, what are the critical numbers? So if I asked you guys, what are the critical numbers of this function, this one, we need to figure out, well, where is the value of the derivative either undefined or equal to 0? Okay, so f prime of x. I totally forget how to take derivatives. Can somebody tell me real quick what the derivative of this function is? 12x to the third minus 12x squared. Cool. Phew. Thank God you guys are here since I forgot how to take derivatives. Okay. So, is this function ever, is the derivative ever undefined? Where? It's undefined at 1? Okay, so we don't need to worry about undefined because it's defined everywhere because it's a polynomial, okay? All right, so next what we have to do is say, well, where is it equal to 0? So then we got 12x cubed minus 12x squared. How do I solve this? Factor? Factor what? 12x squared, and then I'm left with x minus 1. All right, so where's this equal to 0?
At 1.
At x equals 1 and at x equals 0. So that would be my first step. If I just ask you to identify the extrema, I would expect that you find the derivative and find those critical numbers. Okay, so now if I'm doing this on the interval between -1 and 2, where are the possible extrema? Which values for x? 0, 1, I agree, but that's not it. Also at the endpoints, because remember, extrema can happen at endpoints as well. All right, so if I want to figure out now what's the max and what's the min, I just got to put each of those in. So if I plug in -1, what do I get? Oh, where am I plugging that in? The original function, not the derivative. Because I know it's going to happen if I plug my critical values into the derivative, right? What do I get when I plug in -1? I'm sorry? I got 7. Because -1 to the third power would be -1.
Yeah.
Yes? All right, what about when I plug in 0? My favorite number in the world to plug in. 0. And what about if I plug in 1? -1. And if I plug in 2? 48 minus, I think it's 48 minus 32. 16?
Wait. Is it 96 minus 48? Wait.
Nah. 2 to the 4th is 16.
Oh, I was looking at the wrong.
It's 16.
16. Is this okay?
Yes.
So where's my max?
2.
Min?
Are we doing any relatives?
Nah. Is this okay? I think those, I don't think there are, because the derivative isn't, yeah. Are we good? All right, hey, there's a typo in this one. This isn't 3/2, guys, it's 2/3. Because otherwise the numbers get incredibly icky. They might still be icky, I don't know, we'll see. All right, so let's start with our derivative. How am I doing so far? Okay. How would you solve this from here? Okay. So if I factor out the 2, I'd now have 1 minus 1 over the cube root of x, right? Then what? Yeah, I'm just going to add the 1 over the cube root of x to each side. So now I have 1 over the cube root of x equals 1. And then are you cool that in order for this to be true, 1 would also have to equal the cube root of x? And then we would cube both sides, yeah? So x equals 1 is my critical number. All right, so now if I'm testing for maxes and mins.
And 0?
Oh, yeah. Also x equals 0. Why x equals 0?
Because it's undefined.
Because that's where it's equal to, that's where where the derivative is undefined, because you can't have a 0. Yeah? Cool. So now what values for x should we plug in to find maxes and mins? Let's see. Definitely the -1 from the boundary of the interval. 0, 1, and 3. Are we comfortable with this? Do we get -5 for when we plug in -1? And when we plug in 0, I love plugging in 0. What about when we plug in 1? -1. And when we plug in 3?
Decimal -0.24.
-0.24, cool. And that would be sufficient for me. Okay, so now, max, min. What's my min? Max? See? Was I right that today wasn't that bad? All right. Then we got to do this last one. This is the one where you might get mad at me.
Yeah.
Like you are. You're going to be mad at me. I'm okay with it.
Do we have to solve this using two identities?
Kind of, yeah.
Matter.
Kind of. So help me with the derivative. F prime of x equals. Let's see. 2 cosine x minus, or is it plus, 2 sine 2x. Does that feel about right? So we want to see where is this equal to 0, yeah? So I would be like, oh, well, where is 2 cosine x plus 2 sine 2x equal to 0?
What's cosine x, sine 2x? You can factor out the 2.
Okay, so I could factor out the 2. I'm just going to divide both sides by 2, and I'd have 0 equals cosine of x plus sine 2x. I'm fine with that. But
Now we have to do the separating doubles thing.
the separating doubles thing. Does anybody remember an identity for the sine of 2x? It is 2 sine x cosine x.
So smart, Masha.
So what we're going to do is take that sine 2x and turn it into 2 sine x cosine x. And the minute I do that, can we factor now? You got Richards and the choir going right now.
Thank God it's not a period.
The door open.
Was he bad?
It's just like, I don't think that door is any.
Yeah, I'm wondering if there's something I could, like, I feel like I'd get in trouble for, like, duct taping it shut. Like, duct taping over the things, because, you know, it is from the, like, if we ever go into a lockdown, they come in through this door. But,
Well, duct tape is easy to rip off.
yeah,
You could stuff a towel underneath.
make like a cozy to go around the door frame.
Oh, yeah.
That'd be cute.
That could be our next yarn club project.
That'd be really funny. Yeah. Hey, now, so we're left with what? Cosine x equals 0. 1 plus 2 sine x equals 0. Are we comfortable with this?
Yes.
Hey guys, where is the cosine of x equal to 0? Remember, we're on the interval of 0 to 2 pi.
Pi over 2.
Pi over 2, I agree.
Also, um, 3 pi over 4 t.
3 pi over 2. Are we comfortable with this idea?
Yeah.
So, guys, cosine, unit circle looks like this, yes? Cosine is the x-coordinate. The x-coordinate is here and here. Yeah? This is where the cosine is equal to 0. Are we comfortable with this? We good? All right. So now what about over here? For this one, we're looking for where is the sine of x? What's the solution to this one? Sine x has to equal
-1/2. -1/2.
-1/2. All right, so as if we're looking at that unit circle, we're kind of looking for these angles. Do you guys see what I'm saying? That's where because sine is y. So this is, I like to think of it as like the 30-degree angle just past the x-axis, or pi over 6 just past the x-axis, which is 7 pi over 6. Are we comfortable?
Yeah.
What about on the other side here? What's this one? First of all, to get to here, I'm going way a lot, right?
Negative.
But it's got to be between 0 and 2 pi.
0. Well,
So we have 7 pi over 6 and
what is it?
11 pi over 6. If we're comfortable with this as pi over 6, we could do 12 pi over, like take 2 pi minus 11, 1 minus the pi over 6 to get there. So it'd be like 12 minus 1 sixths. Okay. Oh, man. So, now to check for our maxes and mins. We got lots of values. We will have 0. We will have pi over 2. We will have 7 pi over 6. We'll have 3 pi over 2. This is me just going kind of around. We'll have 11 pi over 6. And we'll have 2 pi. So let's kind of split this up. Can each of you plug one of those into the original function and see where we get?
I'll do 0.
Did you get 1? No. Negative
Negative 1.
Negative 1?
Yeah.
Negative 1. I believe 2 pi will also be negative 1. 2 pi will also be negative 1, yeah.
I think pi over 2 is 3.
Okay. I'd buy it.
Is that
Here, I'll double check.
no, it is. Or unless,
Yes.
Did anybody do any of the other ones?
but I could have just lied about the value. You wouldn't know.
Let's see, sine of pi over 2 would be 1. Okay.
No, actually, I pressed grab. It's cute though.
Like a
Say that
cat.
again.
It's like a bunch of cat ears. That's not
11 pi or 7 pi?
11.
And you got 3? Negative 3.
I got, well, I didn't simplify.
Yeah.
Negative 1.5.
Negative 1.5? Okay.
Yeah. Negative 1 again.
For 3 pi over 2, you got negative 1?
You think so? Yeah.
Okay. And then lastly, for 7 pi over 6,
Another negative
negative 1.5?
Yeah.
Okay. Max?
3. Pi over 2.
And then we have 2 mins this time.
Is that it?
Yeah. What do you guys think? Is this okay?
Yeah.
All right, so one of the things I did in that purple packet, y'all, is I tried to, instead of just putting a bunch of problems in, I separated them out by each section. So we just finished 4.1. So those first few problems you should be able to do. So I was trying to do things a little bit better in terms of organization, if that's helpful.
There you go.
And